Coming to the next concept, a single phase AC supply is given to RC series circuit. So here we are applying a instantaneous value of the AC voltage. V is equal to V max sin omega t, and the current which is delivered from the source is I total current, and the current flows through R is IR, and the current flows through C is IC. In a series, the current is same. Always the current flows from higher potential to lower potential, which will produce as a drop across R and C. I am representing the polarities, means it is not at all a DC. During positive of cycle only I am representing the polarities. During negative of cycle, this will be negative and this will be positive, and this is negative and this will be positive. Let us say V is equal to capital V is equal to VR bar plus VC bar. The voltage can be divided across the two elements. V is equal to VR bar plus VC bar. And now I am taking the reference as the current. IR bar is equal to IC bar is equal to I bar. And the resistive component is in phase component. VR and IR, the angle between these two is 0 degrees. With respect to capacitive current, the capacitor voltage is lagging at an angle of 90 degrees. So as we discussed earlier, with respect to voltage, the capacitive current is leading by 90 degrees. If I am taking the current is the reference, the VC is lags by 90 degrees. By adding these two vectors, I am getting the total voltage. Draw a line which is parallel to VR from this VC. Draw a line which is parallel to VC and from this VR. Now I am getting the resultant voltage. The resultant voltage is V bar. The angle between resultant voltage and the current is called the power factor angle. And from this we are getting the voltage triangle. The horizontal component or base component is VR, and the vertical component is VC, and the hypotenuse is V, and the angle is phi. So from this we can define the power factor is a base by hypotenuse component VR by V, the voltage across the resistance divided by voltage drop across resistance divided by total voltage. And V is equal to, I can read it as VR minus J times of VC. Why? Because this is in the negative imaginary axis. So this is in the negative imaginary axis. That's why I put it as minus sign. Or you can write it as VC is equal to I into XC, and V is equal to I into Z. VR is equal to I into R. The property of the impedance true opposes the alternating nature of the current. And if you want to find out the magnitude of the voltage, V is equal to VR square plus VC square, and the angle phi is equal to tan inverse of imaginary part minus VC divided by VR. So from this voltage triangle, if you want to draw the impedance triangle, so VR can be written as I into R, and the VC is equal to voltage across the capacitor is I into XC, where XC is called the capacitive reactance, and the V is equal to I into Z, where Z is called the impedance. So from this, if I am taking I and the cancelled out, and this one is R, this is XC, and now the hypotenuse value is Z. This triangle is called the impedance triangle. Now we can write it as Z is equal to R minus JXC, and the magnitude of the Z is equal to under root of R square plus XC square, and the phi is equal to tan inverse of minus XC divided by R. So Z can be written as magnitude of the Z at an angle of phi. So the phi which is getting here, it is minus. The phi value will be minus. So minus tan inverse of XC divided by R. So we are getting the negative angle. from this impedance triangle and voltage triangle, again we are going for the power triangle. So you should multiply current to the voltage triangle, VR into I, and this is VC into I, this is V into I. And from the voltage triangle, cos phi is equal to VR by V. So now I can write it as VR is equal to V cos phi, and sin phi is equal to VC by V. From this I can write as VC is equal to V sin phi. You should remember these two. And the cos phi is equal to VR into I divided by VI. And anyway, VR divided by V. And this power is called the active power, and this power is called the capacitive reactive power, and S is a complex power or apparent power. And active power is equal to VR into I. So as we know, what is a VR? We are getting from the voltage triangle is V cos phi. So now I can write it as VI cos phi. The units of active power is watts, and the units of reactive power QC is equal to VC into I. I am getting as VI sin phi. The units are var, and the S is equal to P minus JQC. And if you want to calculate the magnitude, under root of P square plus QC square, and the angle tan inverse of imaginary part minus QC divided by P. So S can be written in a polar form, S at an angle of phi. So that phi you should get in the negative in this case. And if you are from the impedance triangle, if you multiply I square to the impedance triangle, I square R, I square XC, and I square Z. What is I square R? Is active power, I square XC is capacitive reactive power, and this is S. And the QC is var, and complex power, the units are volt ampere. And after that, instantaneous power is equal to instantaneous value of voltage into instantaneous value of current. So if I am taking the current is a reference, and the voltage value is lagging, at an angle of phi. So if I am taking the voltage as a reference, the current is leading at an angle of phi. So power is equal to Vm sin omega t. V is equal to Vm sin omega t. Why? Because we are giving the supply is Vm sin omega t. Now I is equal to I max sin of omega t plus phi, and the Vm into Im sin omega t into sin omega t plus 5. So this is in the form of 2 sin A sin B, or cos of A minus B minus cos of A plus B is equal to 2 sin A sin B. So Vm into Im by 2, cos of A is omega t, right? A minus B is cos phi, cos of 2 omega t, plus 5. So now if you want to draw the waveforms of voltage and current, so this is a voltage waveform, and current waveform should be leading, because I is equal to Im sin of omega t plus phi. So at pi it is leading. This is a current waveform. So the angle between these two is, this one is voltage and this is a current waveform. So first mark the 0 positions 1 and 2, 3, 4, 5, 6. At 0 position, if you multiply any value, that should be equal to 0. So this is the position of the waveform voltage. So positive into negative will be negative. Positive into positive will be positive maximum. And positive between 3 and 4, positive into negative is negative. Negative into negative is positive. So positive into negative is negative. The time period for this waveform is pi. So again, average power is equal to 1 by pi integration instantaneous power into d omega t. On x-axis you have to take the reference is omega t. So 1 by pi integration Vm Im by 2 cos pi, the limits are 0 to pi, here also 0 to pi, minus cos of 2 omega t plus pi. So 1 by pi, 1 by pi, so Vm Im by 2, so cos phi integration of 1 is omega t minus integration of cos 2 omega t is 2 omega t plus pi divided by 2. The limits you can apply is 0 to pi. This second term is 0. The second term is 0 and the first term only upper limit you can substitute. You will get Vm Im by 2 pi into cos pi into pi. Pi will be cancelled. So I am getting as Vm Im by 2 into cos phi, and the average power is equal to Vm Im by 2 cos phi. This can be written as Vm by root 2 into Im by root 2 into cos phi. So then it is Vrms into Irms cos phi. So the average power for RL series circuit is finally Vi cos phi. The units of average power is watts. See, if you observe, this waveform consists of a negative portion, a small negative portion and a large positive portion that depends upon the phi value. And here you can define the power factor is it is the ratio of R by Z, and it is the ratio of active power to the apparent power.